Hello everyone. In this lecture, I am going to explain how to draw Nyquist plot for the given open loop transfer function. So that is g of s equal to s plus 2 by s plus 1 into s minus 1. So for the given open loop transfer function, we need to draw the Nyquist plot. So for this, we have to follow some steps. Let us see the solution. Step 1. Step 1. So write g of s in 1 plus st form. So write g of s in time constant form, means 1 plus st form. So the same step we have done in Bode plot also. Now the equation becomes g of s equal to, take 2 common in the numerator. So 2 into 1 plus 0.5 into s in the denominator. No need to change this one in 1 plus st form because already it is in that form only. So no need to change. Write the things as it is. So this becomes 1 plus s into minus 1 plus s. Okay. So now second step. Step 2. So in step 2, we have to substitute s equal to j omega. S equal to j omega. So put s equal to j omega. In g of s in the above equation. Now the equation becomes g of j omega equal to 2 into 1 plus 0.5. In place of s, what should we do? Substitute j omega by 1 plus j omega into minus 1 plus j omega. Minus 1 plus j omega. So now in step 3, we have to find the magnitude of this g of j omega. Find magnitude of g of j omega and the phase angle g of j omega. So before going to find this magnitude and the phase angle of the given open loop transfer function, let me explain the fundamental. Let us consider one complex number, that is z, equal to x plus iy or x plus jy, but make sure it is a complex number. How to find the magnitude for this complex number? We know that root over real part square means x square. plus imaginary part square means y square. How to find the angle for this? Angle z equal to, see here, while finding the angle, uh, observe the sign of this real number and the sign of this imaginary number. So both are positive, means plus plus lies in first quadrant. So what is the angle here? Tan inverse imaginary part by real part. Imaginary part by real part. Another case. Another case. Let us consider z equal to minus x plus iy. Minus x plus iy. See here, the real part sign is what? Negative. And the imaginary part sign is what? Positive. So minus plus lies in which quadrant? It is in second quadrant. It is in second quadrant. So modulus z equal to root over, this is minus x whole square, means x square only, plus y square, plus y square. Here, observe carefully what I told earlier. So this complex number lies in second quadrant. So how to find the angle for this is 180 degrees minus tan inverse imaginary part y by real part x. So like this, we find the angle. Now, with the help of this fundamental, we need to find the magnitude and the phase of this g of j omega. G of j omega. So let us find the magnitude modulus g of j omega. Modulus g of j omega. Okay. See, this 2 is a constant. Here, it is a real number. It is a pure real number. No imaginary part inside. So for this, the magnitude is what? Root over 2 square plus 0 square. So we left with 2 only. For the next term, 1 square plus 0.5 omega whole square. 0.5 omega whole square by root over that for the denominator portion 1 plus j omega. So means what? 1 square means 1 plus omega square root over. So for the second part, minus 1 whole square means it is also 1 square plus omega square. So if we simplify this thing, so we left with 2 root over 1 plus 0.5 omega whole square by root over. So this is, both are same, 1 plus omega square, 1 plus omega square. So shall I write this one as root over 1 plus omega square whole square. So here this root and the square get cancelled. So what is modulus g of j omega? Modulus g of j omega. This is simply root 2 root over 1 plus 0.5 omega whole square by 1 plus 1 plus omega square. Remember this one? This is modulus g of j omega. Modulus g of j omega. So now, next thing is we have to find the phase angle, that is angle g of angle g of j omega, angle g of j omega, angle g of j omega. So for this, see, for the first term, what is the angle? How we find the angle? So this lies in first quadrant. So the angle is tan inverse, imaginary by real. And the denominator, we are having two terms. For the first term, the angle is tan inverse omega. And for the second term, if you observe this one, it lies in second quadrant. Second quadrant. So for this, how to find the phase angle? That is 180 minus tan inverse y by x. So I can write it as like this. Angle g of j omega equal to tan inverse 0.5 omega tan inverse 0.5 omega by root over, not root over, tan inverse 0.5 omega by, for the denominator portion, tan inverse omega plus 180 minus tan inverse omega. Okay. So here plus tan inverse and the minus tan inverse get cancelled. So we left with tan inverse or minus 180 degrees. Take the denominator part to the numerator part. So minus 180 degrees plus tan inverse 0.5 omega. Tan inverse 0.5 omega. So this is phase angle for the given loop transfer function. Okay. So now we are in which step? Step 4. Step 4. So in step 4, we have to calculate the magnitude value g of j omega and the phase value angle g of j omega at omega equal to 0 and omega equal to infinite. Omega equal to infinite. So let us see how to find those two values. If omega equal to 0. So what is the value of magnitude? Means modulus g of j omega. Modulus g of j omega. Okay. So in this magnitude, if you substitute omega equal to 0, this becomes what? 2 by 1 plus 0. Means the magnitude value is how much? 2 only. Magnitude value is how much? 2 only. If omega equal to 0, what is the phase angle? Angle g of j omega equal to. So let us substitute omega equal to 0 in this. This becomes what? Minus 180 degrees plus tan inverse 0. Means the angle value is how much? 0 only. So tan inverse 0. So the value is minus 180 degrees. Angle is minus 180 degrees. Okay. So if omega equal to 0, let us combine the magnitude and the phase angle at omega equal to 0. So the magnitude value is how much? 2 and the phase angle is how much? Minus 180 degrees. Okay. So like this, we need to calculate omega equal to infinite. So for this, what is the magnitude value? G of j omega equal to. See, if you substitute omega equal to infinite. So this is 2 root over 1 plus. Here if you take the omega square common, so this becomes what? 1 by omega square plus 0.5. So in this also if you take omega square common, this becomes 1 by omega square plus 1. So then inside this omega and this omega square get cancelled. So in the denominator part we left with omega only. Otherwise directly you can substitute omega equal to infinite in this. This becomes 2 by infinite. 2 by infinite. Value is how much? That is 0. That is 0. So 2 by infinite. So value is how much? 0. Like that, you calculate the phase angle, angle G of j omega. Angle G of j omega. So substitute omega equal to infinite in this term. So this becomes what? Minus 180 degrees, minus 180 degrees plus tan inverse infinite plus tan inverse infinite. So tan inverse infinite means what? Plus 90 degrees. So 180 degrees plus 90 degrees. So the angle value is how much? Minus 90 degrees. Okay. So if you combine these two at omega equal to infinite, the magnitude value is how much? 0, and the angle is minus 90 degrees. With the help of these two values, now we are going to plot the Nyquist. Okay. So see the Nyquist plot here. Nyquist plot. See how to draw the Nyquist plot. This is 0 degrees clockwise. This represents minus 90 degrees. This represents minus 180 degrees. This is minus 270 degrees. Minus 270 degrees. So in previously we calculated omega is from 0 to infinite, but actually the Nyquist plot is from omega equal to, we need to calculate from minus infinite to plus infinite. Omega is runs from minus infinite to plus infinite. So we calculated the values from 0 to infinite, and the same values will appear on the other side, means the mirror image. So no need to find minus infinite to 0. So let us see how I am drawing this plot. At omega equal to 0. So what is the magnitude value? What is the magnitude value? 2. And what is the phase angle? That is minus 180 degrees. Now start from minus 180 degrees. What is the magnitude value at this minus 180 degrees? Means that magnitude value is 2. That magnitude value is 2. And at omega equal to infinite, what is the magnitude value? 0. And the phase angle is minus 90 degrees. Now the path is from minus 180 degrees to minus 90 degrees. Through minus 90 degrees, the magnitude reaches to 0. The magnitude reaches to 0. So at minus 180 degrees, what is the magnitude? 2. What is the magnitude? 2. Towards minus 90 degrees, this reaches the 0, because at omega equal to infinite, what is the magnitude value? 0. And what is the phase angle? Minus 90 degrees. So that's why the path is taking from 2 to 0 towards minus 90 degrees, and it reaches to 0. So these values are from 0 to infinite. So what I told, from minus infinite to 0, we take the mirror image of this. So we plot from 0 to minus infinite, 0 to minus infinite. So this is the Nyquist plot for the given open loop transfer function. But here the stability of the system depends on capital N, depends on one condition, that is capital N equal to P minus Z, capital N equal to P minus Z, N equal to P minus Z. If the given open loop transfer function satisfies this equation, then we can say the system is a stable system. We can say the system is stable system. So what is the problem he has given? S plus 2 by S plus 1 into S minus 1. So let us place the pole values and zero values on this plot. So S plus 2 means here the pole value is minus 2. The pole value is minus 2. And S plus 1 into S minus 1. So this is S minus 1. The pole value lies in minus 1. This is for S plus 1. So here one pole minus 1. Here I'll change the color. So these are the pole values. Sorry, this is a 0, not pole. This is a 0 because it is in a numerator. So S plus 2 means the pole value is at minus 2. These two are pole values, minus 1, and this is plus 1, and this is plus 1. Okay, so this is plus 1. So now what is capital N? So capital N means number of poles encircled. Number of poles encircled. Number of poles encircled. So what is capital P? What is capital P? Number of poles lies on right hand side. Lies on right hand side. What is capital Z? This is number of zeros lies on right hand side. Lies on right hand side. So this is the meaning of N equal to P minus Z. So let us find the N value for the given Nyquist plot. So N means what? Number of poles encircled. So in this circle, how many poles lies inside this one? Only one pole. So what is capital N value here? 1. Because only one pole is encircled. So that is minus 1. That is minus 1. So let us find capital P value. So what is capital P? Poles lies on right hand side. So capital P value is how much? 1. What is capital Z? Number of zeros on right hand side. On right hand side. So is there any zero lies on right hand side? No. So what is capital Z value there? Z equal to 0. So now what is P minus Z value? What is P minus Z value? That is 1 minus 0. That is 1. So let us check whether this N and P minus Z both are same or not. Both are same or not. So n equal to 1 and p minus z value is also 1. So here n equal to p minus z. So the given open loop transfer function satisfies this condition. So hence the given system is stable system. System is stable system. So for the given open loop transfer function, this is the Nyquist plot, and this is the conclusion of stability. Thank you guys. Thank you for watching.